Hi, we're here to start Chapter 6, which is going to be similar to Chapter 3, except for Chapter 3 was all about lines, and Chapter 6 now is going to be quadratic functions. In layman's terms, quadratic functions are really going to be parabolas generally. It's where you have a variable times another variable, usually it's going to be x squared. And as a physics teacher, I love the parabola because it has, when you throw something, the projectile is going to follow parabolic paths. There's tons of real-life applications that I get totally geeked about. So, title there, Chapter 6, Quadratic Functions. And we're looking at 6.1 today. It's quadratic expressions, rectangles, and squares. And a few things to kind of say relating to that. So first thing, and I don't know if you want to try to get caught up in the writing and pause it, or just blaze on, figure you can catch up. But Roman numeral 1 is going to be, what is a quadratic? And you don't have to write the real generic definition down, but this is a real generic definition. Basically, when you have a quadratic, it's going to be an expression. So it's an expression with one variable times another. So an expression with one variable times another. And that could be, so let's put down a whole bunch of examples. That could be like an x times a y, so I'm going to write down an x times y. It could be like an x squared, which is really just an x times an x, so one variable times itself. Common form is going to be like a ax squared, so some number, 3x squared, negative 2x squared, something like that. Summation of x squared plus bx plus c. We're going to be doing a lot of those this year. We have like a 5x squared plus 2x minus 7 or something like that. So the capital A, capital B, capital C are all numbers, coefficients. And that right there is going to be the standard form for a quadratic, standard form for a parabola, which is what we will get at later. My second part, Roman numeral 2, is a look at example 1, because honestly most of us don't look at the book nearly as closely as we probably should. And this is going to be something that comes up over and over and over in here. So we're looking at like a pool. So the center area, could scribble it in blue, I'll put a little bit here, is the swimming pool. And we have a deck around the swimming pool, could be wood, could be cement. And we're going to have a series of questions relating to that, starting with some fairly simple ones, getting into the more complex. So first thing I want to say is maybe that the width of my pool here is going to be 50 meters. And often, normally in here I don't do much with the units, but I'll at least put them into the original problem. So we have 50 by 20 for our pool. So quite a big pool. And now the width of the walkway around it is just going to be W, we'll say. So there's a W here, there's a W here, W here, kind of going from there and there, a W here, and so on. And we'll come back to those W's. But the first thing I want to get at is just what's the area of the pool. So find the area of the pool. And this is going to be the easier one, because the area is just going to be length times the width. So length, doesn't really matter which one we call which, I'll maybe call it the 50. And then the 20 for the width. It's different than what I said initially, but 50 times 20 gives us a 10 with the 2 more zeros. So we have 1,000. If we were doing the units, it'd be 1,000 square meters. But just the normal area of a rectangle, length times width. The second thing is going to be actually looking at, well, now, what's the length and the width going to be of the whole pool? The pool and the deck, all that combined. So if we're looking at this part here, kind of this bottom section from here to here, well, that includes the 50, kind of this blue edge, but we're also going to have an extra W here, an extra W there. So a lot of times people want to call it like 50 plus 2W, but because we're doing that standard form back from the last slide, it'll serve us well if we put our variables first and call this length here 2W plus 50. That's going to be this whole length of the pool. And now the width of the pool is going to be similar, that we have this height here of 20, but we have this little W here on the bottom, we have a W there on the top, so this one's going to be 2W plus 20 for the overall width of the pool and the deck combined. So if you're putting this thing in your backyard, that's kind of looking at, well, how much space do you need if you want to have the deck and the pool around it. From there then, we jump over into, I'm just going to call this number, well, why not? I'll leave it as 2. And I'll call that the area of the pool and the cement, or area of pool and deck. So area of pool and deck. Whether that's cement or wood or kind of whatever we ended up having. Well, same thing as before. Now the area is going to be the length times the width. But now I'm going to actually take and slide this sucker over a little bit. So if I take these, you can leave yours where they are. I'm just going to run into issues with having my face somewhere on the screen. But now with this here, so area is length times width. Well, my length now is 2w plus 50, and my width is 2w plus 20. So it's not quite as straightforward of a calculation as what we had when we were just getting the area of the pool. And if you think, just on a side note, and I wouldn't actually write this down, but if you had like 3 times 2w plus 50, we'd have to do distributive, because the 3 would have to be multiplied by the 2w, and the 3 would have to be multiplied by the 50. We have the same sort of thing here, but we have 2 binomials, kind of like a bicycle. There's bicycle. You have the 2 parts, the bi. But now we have 2 of those. So now just like the 50 would have to be distributed to the second one, the same with the 2w. So we really are kind of doing distributive twice. And the key word for doing that, if you go back to earlier life stuff, was that we called that like foiling. And I presume that you did that in your intro algebra class a couple years ago. But what that stands for is the F stands for first. That first thing we do is we multiply the 2w times the 2w. And that's going to give us 2 times 2 and w times w. So 2 times 2 is 4. W times w is w squared. So that'd be the F in FOIL. Then the O stands for outside. And now we do the 2w times the 20. So we have the 2 times 20, which gives us 40. And then we have the w still, so it ends up plus 40w. Now we can go through and do the inside, which is the I, so inside. So we have the 50 times the 2w, and that gives us 50 times 2 is 100. Then we still have the w. And then last we have the last. The L in FOIL stands for last. So we do the last thing from the first binomial times the last thing from the second binomial. So we have the 50 times the 20, which gets us back to our answer from before, the 1,000. So plus 1,000. Now the nice part, going back to how I wrote these up here, the 2w plus 50 and the 2w plus 20, is because I put the variable before the 50 and the 20, the number by itself. This here is really close to that standard form that we did before. And whenever you FOIL, you'll always, if you do it correctly, be able to combine the outside and the inside term. So then that gives us, let me scroll down a little bit, so we have 4w squared plus 140w plus 1,000. So now you could go through and say, well, if the walkway was so many feet wide or so many meters wide, what the total area would be. I found that foiling over the years tends to give people grief. So I wanted to put a Roman numeral 3 in here and just do 3 more foiling problems. And usually those come in handy. I'm going to try to throw in some tricks that people stumble on from year to year. So my first one, start a little bit more basic. I just have a x plus 3 as one binomial and then an x minus 2 and the others. And standard form is always write your variables first, numbers that are by themselves last. And we're going to go through and just for each of those we're going to do the FOIL. So maybe I'll go a little bit crazy with the coloring and then maybe do the I, the insides in red, and the L in green. So we'll see if that maybe helps keep everything straight. So when we're doing the first, that's just the x times the x, and that gives us an x squared. Why not? I'll write it here. So that's my first. Then I do my outside, which will be the x times this number. And that's one place where people get stuck, is that you always need to look at the signs that are in front. So technically this is a positive x here on the left. This is a negative 2, which then is going to give us a minus 2x. Now switching over to the insides, we have the positive 3 times the positive x, which gives us a plus 3x. And like I mentioned on the last slide, if you do foiling correctly, the outside and the inside, those two will always be able to be combined. And now when we do the last, in green, we have a positive 3 times a negative 2 for a minus 6, or a negative 6. And then, like always, combine these two together. That gives us an x squared. We start out with a negative 2x, we add 3 to it, which then puts us at a positive 1. I'm just going to write plus x, leave out the 1s, then it's simplified, minus 6. So that's the answer to the first example. Second one, I'm going to throw in a little bit more with the coefficients. So instead of just an x, I have a 2x, then a plus 4, and then an x plus 3. And I'll maybe try to keep the same color scheme here. So I'll do the first in blue. So now I have a 2x times a 1x technically, which gives me a 2x squared. You can view these as you're doing the numbers times the numbers. So 2 times 1 is 2. X times x gives me the x squared. Then if I do the outside, so I have my 2x times my positive 3 for a plus 6x. Then my inside, I have a positive 4 times a positive 1x, which gives me a plus 4x. And then my last, so the last part of the first binomial, positive 4, times the last part of the second binomial, positive 3, for a plus 12. And then we take and combine the outside and the inside together for a 2x squared. Positive 6x plus 4 more gets me plus 10x, and then a plus 12. One more example is all I have planned. Now this one here, every year I put it on the quiz. Every year I put it on the test because it's popular. It's going to come up the more you do math. And every year people tank on it. So please, 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 if you're half awake and your younger siblings are screaming their heads off, pay attention now, go to another room, or get them out of the room. But when you have this x minus 7 squared, it's real tempting to just take the 2 and distribute it in there. But if you think back to other things, and I wouldn't write this, but when you have like a x squared, that's really just saying, well, take that there and make it times itself. So it'd be an x times x. Well, we have to do the same exact thing here with the parentheses. So we can't just say this is x squared and minus 49, but instead we're saying that this whole thing here, everything in the parentheses, is squared, which means then the problem is really x minus 7 times itself, x minus 7. So you can't just distribute the 2 and then get a binomial again. You have to do the foiling, which then is going to give you a trinomial, a 3-part thing like we've had in all the other answers. So as I go through and do my foiling now, I start out with the blue. I have the first times the first. So I do get an x squared. But then from there I do the outsides, positive 1x times a negative 7, so minus 7x. Then my inside in red, so I have a negative 7 times a positive 1x, so another minus 7x. And whenever you have a binomial squared, so something that's a binomial times itself, outside and inside are going to do this. They'll always be the exact same as each other. And then the last, negative 7 times negative 7, gives us a positive 49. So to combine all that together, we combine our outside and inside. We have an x squared minus 14, because we start out with negative 7x, and then we take away another 7x, we go more negative, plus 49. So that's the quick crash course on foiling. So the very last section of the notes, Roman numeral 4, is the binomial square theorem. And with this theorem, it's actually related to that last example that we did. So I'm going to pop back a page and just look at it. And what it's talking about is when we have something like this x minus 7 and it's all squared. So you have a binomial and it's squared. Long story short, you really can go through and do the steps like this. The downfall is it takes a little bit more time. Often it's not going to matter. On the ACT where seconds count, I could try to build a case for you're going to want to memorize this thing. Where it really comes in handy though, and you're going to be doing this a lot as you take pre-calculus and calc, is when you're working backwards. That when you have something like the answer, x squared minus 14x plus 49, and you want to factor it. You want to take it and change it back into a binomial squared. So that's going to be helpful. We do a little bit of that later on this chapter. So Roman numeral 4, the binomial square theorem. And I'm just going to write them out, and then for those that want to stick around and watch the end, I can kind of try to prove why they are the way they are. I'm going to leave the sign out in the middle first, because I'm trying to draw a point. So I'm just going to take and write x with a space and a y, quantity squared, and do that a second time. And the difference between the two is that the first one will make it x plus y, quantity squared. The second one will be x minus y, quantity squared. Now the answers are going to be really similar. That both of them, if we go through and FOIL this, because remember this is x plus y times itself, or x plus y times x plus y, so we'd have to FOIL, which is going to give us a trinomial, a three-part thing. Both of them are going to start out when we do the first, the f and the FOIL, it's going to be an x squared. And then as we go through and do the outside and the inside, those will always be able to be combined. I'm going to leave the sign out here, and that's going to end up being a 2xy. And now the last term is always going to be plus, well, it's the last, the L in FOIL, so it'll end up being a y times a y, so plus y squared. The answer down below, where we have x minus y quantity squared, is going to be exactly the same. I'm leaving out that sign there, so I have an x squared, and then some sign, and then a 2xy, and then a plus y squared. And the difference is going to be that if you start with an x plus y, as you do your outside and your inside, the outside is going to be x times y, the inside is going to be another positive x times y, so we have plus 2xy. As we do the outside and the inside here, you have a minus xy, and then another minus xy. So if you start out with a negative 1xy, take away another 1xy, you're going to end up with a minus 2xy. Some people kind of wonder, well, why is it always plus? And the reason it's always plus is if I were to take this bottom one and say I have x minus y times x minus y. As I go through and do my FOILing, I have x squared, x times x. Then I have, I guess I'll just write it out. When I do my first outside then it's going to have a positive and a negative, so a minus. And I always write them alphabetically, xy. Then when I do my inside, I still have a negative and a positive for a minus. Write them alphabetically, so you have xy. And now I have a negative y times a negative y. The two negatives make it plus y squared. Then if I combine these two here together, I end up with an x squared, negative xy minus xy, like I was saying before, so minus 2 of the xy's plus the y squared. And if I had gone through and done that with the pluses, you get the same exact sort of thing. I'd have the x plus y times x plus y now. So again, this here is the answer for that right there. And now we're kind of changing it to, well, what would it be if we had pluses? You know, what would this answer look like if you're getting this top one? And well, now it'd still be x squared, positive x times positive x, that's the same. But now my outside is going to be a positive x times a positive y, leaving us with a positive xy. Inside then, positive times positive for another positive, and then a y times x, which write it alphabetically as xy. And now last is going to be a positive y times a positive y for the positive y squared, which then gives us this. So you can see how as you were to go through and do them, you're going to get these answers here. And like I said, please memorize that. It'll just make your life easier later. That rounds out all I had to say about section 1. Have a good night.